Hi, this is Alex. I'll be explaining Lab 7, question 2, 3, and 4. Um, First of all, as you can see from the simulation, uh, that would be the numbers I got from this virtual physics lab, and this is my calculation and my drawing. So I apologize for not using color pens. I currently don't have them, but that's the ray tracing. So the ray comes from object here, passes through the first lens, and then projects an image here, just like so. And then this image also projects, the ray also goes through the second lens and then projects the image here, which you can, from the simulation, you can you can find different values for s and s primes and focal length and so forth. So in the second question, we use the thin lens equation to confirm that our graph is relatively accurate. So using this, we find that we know the focal length. It's given in the lab, and we know the as object, so we know the distance between the object and the lens. We can find s prime for the image. It's 6.285 centimeters, so it's roughly the same. It's about 6.3. And for the second s prime, which is behind this lens, we do the same thing. Well, first of all we find S2. So it's the image, S1's image. This is the distance between S1's image to sorry, excuse me. It's the distance between S1's image and the second lens. We know the separation is 15 centimeters. So therefore, the 15 minus S1 prime, we can find that the S2 is equal to 8.7 centimeters, and we use the same calculation to find S2 prime, which is equal to 31.13 centimeters. Well, on the graph it says it's 30.78, so it's roughly 31 centimeters. I scaled it wrong as I wrote meters. It should be centimeters, but yeah, it's relatively the same.